Accelerated Math 6-7 students. We are working in Module 7, and this is Lesson 4. I'm so sorry about my voice, but you already know I've got a cold. So the name of Lesson 4 is, I'm going to try to be loud enough that you can hear me, so if I go in and out, I apologize. But the name of Lesson 4 is called Interpreting Graphs of Proportional Relationships. And so our goal for today, let me zoom in so you guys can see a little bit better. Sorry about my voice, it's really bad. Our goal for today we will practice interpreting graphs of proportional relationships. Our question is, what determines a proportional relationship? So yesterday's lesson showed you a new way to organize information, and I think that tool was really helpful. And so basically what we're going to do from here on out is we're going to expand our ability to organize information so that we can do a little test to check for proportional relationships. And so the way you expand your organizational tool of that table is you just make it bigger, so that instead of having 4 sections, because you remember yesterday you had this one, and then a long skinny one that went right here. Well, instead of having a long skinny one at the bottom, we're going to break that into 2 more sections. So there's actually 6 sections in our organized table. And this is how it works. So in the first space of your table, you put your table of information there. In the second box, it changes a little bit. This is where you're going to look at the table, and you're going to show your work to see if the table is proportional. So this is where you're going to use your x values times a blank equals the y values. All right, and let me find my writing utensil. I just had it, sorry. So again, to remind you, you're going to take your x value times the constant or the unit rate, and that gives you the y, right? And so you're going to take that information that you have here, and you're going to test each one of your amounts that are inside there, and you're going to look for a common constant unit rate that goes all the way through. If you do find a constant common unit rate that goes all the way through, then over here you're going to write the equation that it took to find the constant. And remember, the equation that we used is we're determining what that constant is. So you would say the unit rate is the same thing as the constant. And so you will just write what that constant was. So what you found that followed in each one is what you write as the constant. Then what you're going to take is you're going to take your table information and you're going to graph it. And you're going to remember that there are 3 things that we have to have on the graph to prove that it's proportional. So if your graph shows you that it's proportional, then you get to put a check in the box next to each one. So if it goes through the origin, you get to put a check. If it goes through the straight line, you get to put a check. If it goes through or if it has a constant, and you can see the constant steps on each one of the changes, you put a check. And then the last thing is that you get to write an equation that includes the constant rate of change. And remember that equation that I taught you several lessons ago? The equation sounded like this. Y is a result of something times x, and we called that something an m. And that's something, so that was just a variable that will help us remember. This m stands for unit rate, or constant. That's what the m stands for. So you're going to write the equation so that it would say y equals whatever was our constant, and as long as it showed up on your graph, you would write that constant right here in the blank, and then you put times x. Okay? All right. So this is just another way to organize all your information so that you can double check, because our goal is we're going to practice interpreting whether graphs are proportional, okay, and then what determines a proportional relationship. So I gave you a little practice problem down at the bottom because I want you to try using this table, and I think that you'll like it. So it says, what's the relationship? Grandma's special chocolate chip cookies recipe yields 4 dozen cookies. It calls for 3 cups of flour. Use the organization table to show the relationship. Okay, so if it says that one recipe can make 4 dozen cookies and it calls for 3 cups of flour, then that means that you need 3 cups of flour for every 4 dozen cookies. So the first thing that you need to think about is, what are you comparing? Can the cookies exist without the flour? So the answer is the flour is going to be the independent because flour is flour. Whether you make it into cookies or you make it into tortillas or fry bread or whatever it is that you decide, it's still just flour. It doesn't turn into anything else until you do something to it. So that's why we're going to say the flour is the independent. And then the cookies depend on the flour because if you don't have flour, you can't make cookies. You can't even see. Okay, so flour is the X, right? Cookies is the Y because the cookies depend on the flour to become real. All right, so now it says in the recipe that we have for every 4 dozen cookies, it takes 3 cups of flour. So I actually am going to go down in my table 2 spaces, and here's why. In order to grasp something, it has to go through the origin. So I'm going to put that one on there, right? Then we're trying to find the unit rate. So I'm going to say for every 1 cup of flour, how many cookies will you get? And then it tells us that it takes 3 cups of flour to make 4 dozen cookies. So remember, these are dozens of cookies, right? So I get to put that here, all right? So now it says use the organization table to show the relationship, and so I know how to do this. So again, remember we're using this to help us prove it. So X value is 0 times what number gives me 0, because anything times 0 is still 0. So then I will go to 1 times what equals, and right now we have to leave it blank because we have to figure out what the unit rate would be. So here we have 3 times what number gave me 4. So to help us out so that we can figure out what we're going to do, another one that I would say right here is let's put a 2 and let's put a 3 here. Oh, we already have a 3, so let's make that a 4. Sorry, I don't have an eraser, so I'm going to just have to color it in. That's a 4. All right. So something that can help us is if we write it this way. If I'm trying to get for every 4 dozen cookies, there are 3 cups of flour, and I'm trying to get to 1 because that's where I want to get. How did I get from 3 to 1? I divided by 3. What you do to one side, you have to do to the other. So 4 divided by 3 gives you 4/3, right? So now what we have to do is this is our unit rate. And our unit rate would be, if you changed it into it, you would see that our unit rate is 1 1/3. So that tells me that you take 1 times 1 1/3, and that gives you 4/3 dozen. 4/3 dozen. What happens when you take 3 times 4/3? If you take 3 times 4/3, you get 12 divided by 3, which is 4. So it would work. So we could say that our unit rate or our constant is 4/3. So if we put 4/3 in here, 4/3 up here, right? So 0 times 4/3 is still 4/3. 1 times 4/3 gives us 4 divided by 3, which is 1 1/3 dozen. 3 times 4 is 12, divided by 3 is 4. Good. So now we have to do 2 times 4/3, right? So I get 4 times 2 is 8. 8 divided by 3 is 2 and 2/3, right? And then we have the last one is 4 times 4/3. Well, 4 times 4 is 16 divided by 3. 16 divided by 3 would go in 5 and 1/3. All right, and so we have up here, we have 0 dozens of cookies. If you had 1 cup of flour, you would have 1 1/3 dozens of cookies. Then if you had 3 cups of flour, you would have 4 dozens of cookies. If you had 2 cups of flour, you would have 2 2/3 dozens of cookies. And if you had 4 cups of flour, you would have 5 1/3 dozens of cookies. Okay, so that helps us figure that out. And now if we look at this work right here that we did, we would find that our constant is 4/3. Or if you want to write it the other way, you can write 1 1/3. But we've had the discussion that you're just going to have to turn this back into a fraction greater than 1, so I would leave it at 4/3. All right, so now what we have to do is we have to graph it. Okay, so we're using our table, and we're going to graph it. So we're going to say down here is cups of flour, because that's our independent variable. And this one over here, we're going to write dozens of cookies. And as you already know and you've been learning, we have to label everything. bottom, dozens of cookies on the top. Our first ordered pair is 0, 0. So we have to go over 0, up 0, put a dot. Okay? So if we're trying to figure this out, let's say the highest I have to go to is 5. So let's see what happens. 1, 2, 3, 4. Oh, that will work. So this is 1. This is 2. This is 3. This is 4. That would be 5. That would be 6. And that would be 7. Okay. And then over here, we have to go up to 5. So we'll go 1, 2, 3, 4, 5, 6, and 7. Okay. So now it says for every 1 cup of flour, we have 1 1/3 dozen of cookies. I'm going to say it's that right there. Okay. The next one says 3 cups of flour gives us 4 dozen cookies. Okay. 2 is 2 2/3. So here's 2, and then 2/3 would be about there. All right. And then 4 gives us 5, which is right there, and 1/3. It's about right there. Okay. So now I've graphed. Sorry, I forgot to write the ordered pairs. So we'll put them all right here. 1 1/3, 3 4, 2 2/3, and 4 5 1/3. Okay. And so then we have that to show it. Okay. And then what we do from there is we do the checklist. So did it go through the origin? Yes, it did. Is it a straight line? Well, let's check it and see. Let me grab this straight edge and we will draw it and see if all the lines connect, right? And if we had it exactly in the space, I would say yes. So is it a straight line? The answer on that one would be yes. And is there a constant? So let's look. For every, you go up 1 1/3, you go over 1. So go up 1 1/3 and over 1. Up 1 1/3 and go over 1. Right? Up 1 1/3 and go over 1. So what do you notice that we have everywhere? Is there a constant? The answer is yes. So we have check marks in all 3. And so now we get to do our last step. And our last step is to write the equation. So we know that for any y to exist, we must take 1 1/3 or 4/3 times any x value. So what if I gave you 10? What would we have here? Well, 10 times 4 is 40. 40 divided by 3 is 11 and some leftovers, right? So it still would work. You would get 11 and some leftovers, dozens of cookies. All right? So any value of x would result in a y once you multiply it by 4/3. So we can conclude that Grandma's special chocolate chip cookie recipe is proportional because it follows all of the things that we have to do. Okay? So going back to our goal, today we will practice interpreting graphs of proportional relationships. We did by looking at those, yes. And then the question that we had to do was what determines a proportional relationship? Well, now you have an entire table that shows you how to check it. So if you're working at tables, here's how you prove a table is proportional. You find the unit rate, then you graph your graph. If it has these 3 checkpoints, then you get to write the equation that supports it, and that's how you know it's a proportional relationship. All right? And that's all I have for you in this lesson. I'll see you all tomorrow. Bye!